Okie dokie, so when we're looking to see if something is polynomial, we're looking for fractions in the exponents and x's in the denominator. Either one of those cases will make it not a polynomial. So this first one has a fraction exponent, so this is not a polynomial. This one has a fraction in the coefficient, but that's fine. Your exponents here are both nice numbers, and there's no x's in the denominator. There's a 5 in the denominator, but that's fine. So this is a polynomial. For the end behavior of each polynomial, remember we want to look at the degree, which here the highest power is 3, and the leading coefficient, which here that number in front of that term is 2. So this is odd for the degree and a positive leading coefficient. Odd is opposite, so positive means we will start down and then go up. And so if we describe this, first we'll say x going to infinity, so that's going to be the right, so that will be this direction. F of x will go up. And then x going to negative infinity, that's to the left, so that will be this direction. So f will go down. So this is your final answer here, describing the end behavior. Here for this one, the highest power is 4, leading coefficient is -1, so degree is 4, leading coefficient is -4, so this is even and negative, so that means both will go down. So as x goes to positive infinity or to the right, the function will go down. And as x goes to negative infinity or to the left, the function will also go down. Here for this one, the degree is 3, leading coefficient is -2, so this is odd negative. So we will go up and then down because odd means opposite. So here as x goes to positive infinity to the right, so this is the right hand arrow, the function will go down. And as x goes to the left to negative infinity, so that's the left-hand arrow, the function will go up. For this guy over here, we're going to have to work a little bit harder for our leading coefficient and our degrees, because remember, we'll have an x cubed from this first term, we'll have an x from this term, and an x squared from this one. So we've got to add all of those powers together. So the degree will be 3 plus 1 plus 2, so that'll be 6. And our leading coefficient is this 6 in the front here. You still get to look at the number in the front for the leading coefficient. So here, the degree is 6, leading coefficient is 6, so this is an even degree, positive leading coefficient, so both will go up because even means together. So as x goes to the right, the function will go up. And as x goes to the left, the function will also go up. Now we're finding the solutions for each polynomial. So we'll start by factoring. We'll set our factors equal to 0, and then we'll solve. So here for this one, we'll start by factoring. We're looking for two numbers that multiply together to get 36, add together to get -13. So that will be, sorry, I will not put an X there. 9 and 4, so -9 and -4. But remember here, because this is an x to the 4th, we have to put an x squared and an x squared here. It can't just be an x. So now we will set each of these factors equal to 0. Add 9 here, square root both sides. Don't forget your plus or minus. And we'll get x equals plus or minus 3. And then over here, add 4. Square root both sides, don't forget your plus or minus, and we'll get x equals plus or minus 2. So we have 4 zeros here. We have 3, 0, -3, 0, 2, 0, and -2, 0. And these all have multiplicity of 1. If you wanted to check that part, because if you looked at your factored version here, There's only one of each factor, right? So you got 2 zeros from this factor with the x squared. That's what the x squared means. That'll be 2 zeros. You got these 2 zeros. And then you got 2 zeros from this factor. But there's no like 2 up here. So those all just have multiplicity of 1. Okay. Now for number 8, similar type of thing. Two numbers that multiply together to get -5, add together to get -4. So that'll be -5 and +1. Again, we need an x squared and an x squared because this is x to the 4th. So now we'll set those each equal to 0. Here we'll get x squared equals 5. Square root both sides. Don't forget your plus or minus. And you'll get x is equal to plus or minus radical 5. Over here we'll subtract 1. Square root both sides. Don't forget your plus or minus. But here the square root of -1 will be I. So here we'll have plus or minus I. So these are imaginary solutions. So there's no zeros for those imaginary solutions. But for this guy we'll have square root of 5, 0, and negative square root of 5, 0. Each of these has a multiplicity of 1 because there was only one factor here. You got 2 zeros from there, that's why there's an x squared. And then technically there was 2 more zeros here, that's why the degree is 4, but those are imaginary, so they're not going to be x-intercepts. All right, for number 9, it's already equal to 0. We have 2 terms here, so first look for your GCF. So here we have an x to the 4th that we can factor out. That'll leave us with 7x minus 4. That's all the factoring that we can do, so now we'll take each factor and set it equal to 0. Here we just need to do the 4th root of both sides. Technically you should have a plus or minus there, but since it's just 0, it'll be technically plus or minus 0, but it's just 0. And then 7x is equal to 4, divide by 7, x is equal to 4 over 7. So here we will have 0, 0, and 4/7, 0. If you want to look at the multiplicity, this guy here was a power of 4, so the multiplicity here will be 4 for this one, and this one came from this factor, so this only has a multiplicity of 1, and altogether that's 5, so that matches the degree. All right, for this guy down here, it's not equal to 0, so to start, we're going to move the 2x squared over to this side. Make sure we put it in order, so we'll do x cubed plus 2x squared next, minus 4x stays the same, minus 8 stays the same, and then it will be equal to 0. Make sure not to forget to do that before you start factoring. Always equal to 0 first. This is 4 terms, so we'll do grouping. We'll pull out an x squared on this side, and we'll have x plus 2. Pull out a 4, bring that negative with it that's in the front here, and that will leave you with x plus 2, because -8 divided by -4 will be positive 2. These have an x plus 2 in common, so we pull that out, and then we have x squared minus 4 left, because that's what's right here. So now we have factored. Once we factor, we take those factors and set them equal to 0, so we'll set x plus 2 equal to 0. That'll give us x equals -2. And then I'll do this one up here, x squared minus 4 equals 0. Add 4, square root both sides, don't forget your plus or minus, and you'll get x equals plus or minus 2. So for our zeros, we have positive 2, but then we got -2 twice, because we got -2 here and here. So we have -2, 0 is the only other 0. So this one will have a multiplicity of 1, but this one will have a multiplicity of 2. And altogether that's 3, which adds up to the degree. Okay, over here we need it equal to 0, so we'll move the 18y over to this side first. Look for our greatest common factor here. Both are divisible by 2, 18 and 2, and then we have a y. So we'll pull that out. That'll leave us with y squared minus 9. You can keep factoring because that's a difference of squares if you would like, or you can just start setting it equal to 0. So we'll set 2y equal to 0, and y squared minus 9 equal to 0. Here we'll divide by 2 and get y equals 0. Here we'll add 9, square root both sides, don't forget our plus or minus, and we'll get y is equal to plus or minus 3. So here our zeros will be 0, 0, 3, 0, and negative 3, 0. These guys came from this factor, which there's only one of, so these will each have a multiplicity of 1. You got 2 zeros from there, that's what the y squared tells you. And then this guy came from this factor, which there's only one of, so each of these only has a multiplicity of 1. Alrighty, now this one we want it equal to 0, but the highest power is over on this side, so I'm going to move everything over there. So we'll leave a 0 on this side. Keep our highest power first, then our next highest power, but then I'll subtract x and subtract 1 to move these guys over to that side. That way you don't have any negatives. Now we have to do grouping, because there's 4 terms. So we'll factor out a 9x squared on this side, because they both have a 9. That'll leave us with an x, and remember when you don't have anything left, it's a 1, because you're dividing, right? When you multiply it back out, it has to end up being what you started with. Over here, there's nothing in common, so we'll pull out a 1. We'll take that negative in the front with that and pull that out. And that'll leave us with x plus 1, because negative 1 divided by negative 1 is positive 1. So that'll leave us with x plus 1 and 9x squared minus 1, because you factor out the common factor, and then what's left is 9x squared minus 1. So this is all equal to 0 still. So now we will set these factors equal to 0. For here, we'll get x equals negative 1. Here we'll add 1, and we'll get 9x squared equals 1. And then we'll divide by 9, and we'll get x squared equals 1/9. And then we'll square root both sides. Don't forget your plus or minus. You can do this in your calculator, but square root of 1 is just 1. Square root of 9 is 3, so this should be plus or minus 1/3. So we have our zeros here will be negative 1, 0, negative 1/3, 0, and 1/3, 0. Each of these has multiplicity of 1 because both of our factors here only happened one time. Okay, so these are each have multiplicity of 1. All right, on to the next problems. So we're stating the degree, the zeros, and the multiplicity, and the y-intercept. So for the degree here, because it's already factored, you do need to take into account each of these. So from this one, we'll get an x to the 1, this one an x to the 1, and this one an x to the 1. So add all this together, and the degree will be 3. Your leading coefficient would also be 3 because of this guy right here, but it didn't ask us about that. For zeros, we'll get a 0 from this guy. If you set this guy equal to 0, you'll get 3. So you'll get 1, 0 is 3, 0. That only happened one time, so the multiplicity is 1, which means that will cross. This guy here, if you set him equal to 0, I won't do all this work every time, just a reminder of what we're doing. You'll get negative 4, 0. That only happened once as well, so multiplicity of 1. That will also cross. And then here, x plus 7, set that equal to 0, and you'll get x equals negative 7. So this will be negative 7, 0, multiplicity of 1, because it only happened one time, and that will also be a cross. So you don't need this last 0 here. And then for the y-intercept, remember you're just plugging in 0 for x into the original. You can type that all into your calculator or do it by hand. You'll have 3 times negative 3 times 4 times 7, and you'll get a huge number for this one, negative 252. All right, for number 14, You'll set each of the factors equal to 0. Just don't forget about this guy. You still have to set that equal to 0. So you'll get 0, 0 for that guy. It only happens once, the multiplicity of 1, which will be a cross. For this guy, if you set it equal to 0, you'll get 5, 0. That has a multiplicity of 2 up here. So that will be a bounce. This guy here, set that equal to 0, and you'll get -2, 0, multiplicity of 2, because of this guy up here, which will also bounce. And then the last one, if you set this guy equal to 0, you'll get -6, 0, multiplicity of 1, and that will be a cross. And then to find the y-intercept, we're plugging 0 in for x. And you'll get 0 times 25 times 2 times 6, which will be 0. Or you could just type the whole thing into your calculator. Either way, you should get 0, 0. All right, for this guy down here, before we do anything, we do have to factor. So let's come over here because it's not factored yet. You can put the degree down though. The degree here is easy to spot because it's just the highest power. Oh, we didn't do the degree up here for this one. Skip that one for number 14. So you're gonna have a 1 from this x, a 2 here, a 2 here, and a 1 from this x. So you're gonna add all those together. So 4, 5, 6 should be the degree. If you've done it correctly, your degree should add up to all your multiplicities. So you can check that. So if you look here, our multiplicities add up to 3. Here, they add up to 6. So that can be a good check. You shouldn't depend on it, because if you do something wrong with the multiplicities, you'll get that wrong, but it can be a good check. Okay, so here we'll have to factor. So let's do that over here. It's grouping because there's 4 terms, so we'll put the line down the middle. On this side, we'll factor out an x squared. That'll leave us with x plus 4. Over here, there's no common factor, but we'll plot a 1 and this negative in front with it. That'll leave us with x plus 4, because -4 divided by -1 is positive 4. So the one we have in common is x plus 4. That'll be one factor, and then the other factor will be what's left, squared minus 1. So now that it's factored, you might be able to see this one will give you -4, 0, with a multiplicity of 1. This one you might need to set equal to 0 to finish solving that one. Square root both sides. So from this one you'll get +1 and -1, 0. Now that came from this factor, right? Which there was only one of those factors. There wasn't like a 2 here. There was only one of those. So since there's just a 1 there, this is still multiplicity of 1 for both of these. So these would all be crosses. And you don't need this last 0. And then for the y-intercept, we're going to plug in 0 for x. And we'll get -4, so this will be 0, -4. All right, we got to factor this guy as well. We're going to look for 2 numbers that multiply together to get 16, add together to get -8, so that'll be x minus 8. Or you can write that as x minus 8 squared. Ooh, sorry, we got to have an x squared here. No, 4, not 8. What am I doing? 4 times 4 is 16. So -4 and -4. These have to be an x squared because of this guy right here. So then we'll set those equal to 0. Square root both sides, plus or minus. And you'll get plus or minus 2 here and plus or minus 2 here. You could have also rewritten this guy as x squared minus 4 squared if you liked that better. But no matter what, that means that 2 happens twice. So we get the 0, 2, positive 2, we get that twice. And we got negative 2 twice. So the multiplicity is 2 for both of these. And then the degree is 4 because that's the highest power. Don't need these zeros. And then for the y-intercept, we'll plug in 0 for x. And we'll get 16. Okie dokie, let's do some graphing, and then we'll do some matching. So sometimes when you're doing the graphing, you might have to factor it yourself, which like some of the ones that we factored up here on the previous page, you could practice those. We also did one in the class together, but I've factored both of these for you just to make it a little bit easier. So first we'll find our zeros, so we'll look at both of these if you want. You can set them equal to 0 and solve. A lot of times I skip this step because, you know, a lot of you can kind of see what the zeros will be. So we'll have 2, 0. This has a multiplicity of 2 because it came from there, so that will bounce. Negative 3, 0. This came from this. That has a multiplicity of 1, so that will cross. The y-intercept will plug in 0 for x. Bring this down a little bit. So this will be a negative 4 times 3, which will be negative 12. So our y-intercept will be 0, negative 12. Or you can just type that onto your calculator. The degree here, you're going to have to add them up because it's factored, so you need the 2 and 1 together, so that'll be 3. The leading coefficient here will be negative 1 because that's what's in front here. And so we have odd, negative, so that means opposite, so we'll go up because it's negative and then down. So this says as x goes to the right, so that'll be this arrow, that'll go down. And then as x goes to the left, that'll be this arrow. We're going to go up. Turning points is always 1 less than the degree, so this will be at most 2. Okay, so now we can graph. We'll start with our arrows, then put our zeros on here. 2, 0. Oh, no, sorry. And negative 3, 0. And then we have a y-intercept at negative 12. So put all the zeros in the y-intercept, and then we're going to connect. Now at negative 3, so we'll go first to negative 3. I'll start at the 0, go to negative 3 first. Here we're crossing, right, at negative 3, 0, so we'll go right through. Now I can't go straight over to this guy yet, right, because I can't cross the y-axis here. I got to cross it all the way down here. So I got to go down here to cross the y-axis. Then I'll come up here to the 0. I'm definitely going to touch the x-axis here, but at 2, 0 we bounce, right? So I'm not going to go through. I'm going to touch the x-axis and come back down. All right, for this 0 right here, it will be negative 2, 0. It has a multiplicity of 1. That'll be a cross. This one will be negative 1, 0. Multiplicity of 3, that'll be a wiggle. To find the y-intercept, we're going to plug in 0 for x. You can type that into your calculator, or you get 2 times 1, which will be 2. For the degree, we'll have to add all of these guys together for this one, so this will be 4. Leading coefficient will just be the invisible 1 in the front. So this will be even, positive. So both up. So as x goes to the right, this will go to positive infinity, and as x goes to the left, this will go to positive infinity as well. Turning points is one less than the degree, so this one will have at most 3. So we'll start with our arrows. And then we'll put our zeros on here. And our y-intercept. And then we'll connect the dots. The first 0 we'll get to will be -2, and here we're going to cross through the x-axis. And then we go to -1. This is going to be kind of hard to see, but we do have to wiggle at -1. So we'll cross through the x-axis, but we'll wiggle through it. So if you zoom in, you might be able to see my wiggle. And then we'll cross through the y-axis and go all the way up. So wiggles is crossing through as well. It's just how you cross through. You kind of wiggle through. This is what a wiggle is supposed to look like. This is a wiggle. But when it's so small, it's kind of hard to see. All right, now let's talk about some matching. So I'm going to tell you the strategies that I think are helpful for problems like these. And then, here, I'm going to change my camera a little bit here so we can see the whole page at once. Because you could solve every one of these and find lots of information, but they recommend, right, using like your leading coefficient test. So this is end behavior, your y-intercepts and zeros to match each function to its graph, right? So when I look at this problem, I actually wouldn't probably start on the problem number 24. I'd probably start on some of these where the zeros are really easy to find. So like, I would probably start with question 35, maybe. Because I see just really obvious zeros here, right? So 35, this will have a 0 at 1, 0. One at 3, 0, and one at 5, 0. And they're all going to be a multiplicity of 1, so they're all going to cross. So if we can find a graph where 3 zeros at 1, 3, and 5, where it's just crossing, then we know that that's going to match. And if there's more than one, then we might have to narrow it down. But we're looking at no bouncing, no wiggles, just crossing. 1, 3, and 5. So if you look around at your graph to see crossing at 1, 3, and 5, over here at A, looks like we cross at 1, 2, 3, 4, 5. So this is going to be A here. So then I would do the same thing for any other ones where I think it's pretty obvious to see the zeros. So I will look at 37 maybe next, because this one has clearly 3 zeros. We've got 4, 0, which will be a cross because it's only a power of 1. We got 3, 0, which will be a cross because it's only a power of 1. And we've got 1, 0, which will be a bounce because it's a power of 2. So now I can try to find something with a bounce at 1. So if I look at these graphs, this one looks like it has a bounce of 1, but it crosses at 4 and 3, which is not the case there. This one crosses at 0 and negative 1-ish. So I want to bounce at 1, find any other ones that bounce at 1. Well, this one bounces at 1, O, and it crosses at 4 and 3. So this is going to be my graph, and I'm going to cross them off as I go. So we crossed off A, and we crossed off O. 38 also looks pretty nice. It has some clear zeros. So here we'll have a 0 at 1, 0, 2, 0, and 3, 0. This will be a cross, this will be a bounce, and this will be a cross. So now we're bouncing at 2. So looking around in my graphs, looking for a bounce at 2. This one has a bounce at 2, okay. And we're crossing at 1 and 3, so I think this is it, because we're crossing at 1 and 3, and I don't see any other ones that cross at 1 and 3. So K will be this one. 34 also has some nice zeros here. So 34, we're going to have a 0 at -3, 0. That will be a bounce because the 2. And then we're also going to have a bounce at -1, 0. So bouncing twice at -3 and -1. So if I can find something that bounces at -3 and -1, I think that's M down here. Don't see anyone else that does that. So this will be M. Let's look for some other ones that have some nice zeros. I think 31 does, right? So here you'll get 0, 0 from this guy, if you set that equal to 0, and that will be a bounce because of the 2. And then you'll get 3, 0 will be a wiggle because of this guy. So we'll have a bounce at 0, 0 and a wiggle at 3. So bounce in the middle. This one has a bounce, I has a bounce at 0, but it doesn't have a wiggle at 3. It crosses at 3, so that doesn't work. Where else? This one has a bounce at 0, L. But it crosses at 2 and 4, so that doesn't help us. Where else are we bouncing at 0? J here, we're bouncing at 0. Oh look, and we're wiggling at 3. This is a wiggle right here, so this is our next one. So this will be 31. And then I think we've hit most of the ones that have all their zeros pretty obvious. So from here, I probably would just start going down the list and looking at end behavior and fact zeros if that's easy to do. So like this one here, it'd be easy to factor this one myself, 24, factor out an x squared. And now it's pretty obvious that we have 0, 0 from this one. That will be a bounce because of the square, and then we'll have 3, 0 from this one, which will be a cross. So let's look at, I think we saw a 0, 0 bounce and a 3, 0 cross earlier. Yeah, that was I right here. So this one's I. This 125 just is the line, so that's B. 26 is pretty easy to factor too, just like the last one, x cubed, bring that out. So now we'll have here 3, 0 will be a cross and 0, 0 will be a wiggle now because of this guy. That'll be a wiggle because of the 3. So I think we saw that one earlier as well. 0, 0 was a wiggle, 3 was a cross. That was this guy right here. Well, maybe we didn't see that one earlier. So this is wiggling at 0, 0. So that's H. Let's see, 27, you could factor that one. You might need to. The end behavior, you could look at the end behavior for 27. So let's look at 27. We'll do the end behavior. This is going to be an even power and a negative leading coefficient, so that's going to be both down. So if we look at which ones are both down, we have a couple options here. We've got F and N. So both of those have 2 zeros. So we probably do need to factor it to see what our zeros are here because we don't know. Both of those are both down. So let's factor 27. So that or solve for equal to 0. So you can factor it if you want into two factors, or you can just set it equal to 0. So then I'll have negative 4x squared minus 9 divided by negative 4, and you get x squared equals negative 9 over 4. No, negative 9 divided by negative 4 will become positive 9 over 4. Square root both sides, and you'll get plus or minus 3 halves, because the square root of 9 is 3, and so one's positive and one's negative. So that's not f, because f is both is positive, so that would be n here. So this guy will be n. 28 is just a constant, so that's just your straight line. That's g. For 29, we can think about the end behavior if we want first. It's odd and negative, so that will be up and then down. For 29, here, I'm going to start keeping track of this over here. So for 29, we're going to go up and then down for the end behavior. We've got a couple like that. So it could be C or it could be E. So why don't we factor 29 and see what happens? So we'll factor out, I'll do it over here. Factor out an x, no, a 2. You can pull out a negative with it if you want, but at least a 2x. Then you'll have negative x squared plus 4. So you'll get 2x equals 0, divide by 2, and you get x equals 0. Here, add x squared, you get x squared equals 4, square root both sides, and you get x equals plus or minus 2. So, and these will all be cross, because it's just 1 for each of these. So we'll cross at 0, 0, 0, 2, 0, and negative 2, 0. Those are all crosses. So this E is too wide. That's 3 and negative 3. This one is 2 and negative 2. So we're at C here for 29. 30 is our other odd and negative. So this will also, 30 will also have odd, negative, and behavior. So that must be E. If you factor that one, you'll probably get this zeros there closer to 3. But it's the only other one that has that odd behavior, so we can go ahead and match it. Let's look at the end behavior for 32. 32, highest power is 4, even, so that will both be up. This guy is even negative, so that will both be down. And all we have left is 36. 36 is also even positive, so those will both be up. So we know that 33 is going to have to be the one that has 2 down, so that'll be F. But 32 and 36 are both facing up. And our last two we have left are both facing up. So let's factor 32 to see what that is. I'll do that down here on the right. So we have x to the 4th minus 6x cubed plus 8x squared. We have a greatest common factor of x squared, so let's pull that out. That'll leave us with x squared minus 6x plus 8. We can keep factoring that. Two numbers multiply together to get 8, add together to get negative 6. That'll be negative 4 and negative 2. So our zeros here will be 0, 0 from this guy. That will be a bounce because of the squared. We'll get 4, 0 from this guy, which will be a cross, and 2, 0 from this guy, which will be a cross. So we're bouncing at 0, 0, which L is the only one that's bouncing at 0, 0. This one is crossing at 0, 0. and then crossing at 4 and 2, so that matches. So L is our 32, and that leaves 36 to be D. There you go.